going to invite the panelists up on stage for a Q&A. Need a little help with the audience questions. Are there anybody from ARC here? Please stand up. All right, we need volunteers. We need volunteers to run the mic. Who here needs a few more steps on their Fitbit? Okay. I ask you, go to the audiovisual. Okay, thank you, Alan. Anybody else wants to volunteer as well? Okay. Come on up, gentlemen. You're going to notice that there's a new face here. Hadn't got a chance to speak yet. That's Bernard Escherman. Okay, wave to the crowd. He's from ABB. So he hasn't had a chance to talk yet, so I'm going to put him on the spot right away. All right, our autonomous operations means a lot of things to different industries, banking, automotive. Tell me about what it means to our industry, our automation.
Yeah, and I hope I don't actually make you even more confused by introducing an additional reference framework. But I would actually like to describe it in 3 different types of situations that we typically have in the industry. One is normal operation, the other one is start and stop, and the third one is everything else, the unusual things that happen, whatever, a pump starting to fail or whatever. If you look at the normal operations, obviously the biggest benefits of going beyond the normal automation is by integrating more information, either horizontally or vertically. By tying it up, you heard about the value chains that you actually have a connection to the mom. Actually, the value chains, I want to add one comment because that is something that is probably sometimes neglected. Everybody's talking about sustainability. Sustainability means that a lot of the stuff that is driven by whatever gas will become electric in the future. And if you want to have renewable electricity, obviously that's not always available. So you will have to think about what is the action in your process that you do in case you have to do some load shedding, in case you have to manage the power. Yeah, so all of these things have to be integrated into the normal operation. If you go to the start-stop, I don't spend any time. Both Mike and John talked about state-based control for long enough. So let's stay with the most difficult part, the unusual things. Yeah, the unusual things are the things that are also difficult to handle by the operators, especially if you've got new ones who don't have the experience of 30 years. Now you could say, okay, let's use AI to deal with that. And obviously, that is a way that you can always complement the knowledge of the operator by using a lot of data analysis. Computers are extremely good in doing data analysis, whereas people are not that good in that. But if you're talking about unusual situations, unfortunately, that's the ones that you don't find in your data often to learn from. Yeah. Obviously, there are things that you can do to account for that. Many industries do HAZOPs in the beginning of the operation. And that's exactly analyzing what would happen in case something unusual was happening. And of course, you can start from that and say, well, based on that, for example, I create simulation values that help my learning algorithm to learn these kinds of situations that in reality don't happen. Or you can do other things with the HAZOPs. But that's something that you can do in order to support the operator. You can also help the operator by means of doing very quick simulations of what if scenarios. If I now did that thing, would that help me in keeping the plant alive? Things like that. And finally, if you look at all of the possibilities that you have with remote operations, Obviously, you don't necessarily have to have people on site. When you can tie in a number of experts from outside of that site in a quick way, especially if you're able with this data-based analysis to see anomalies early on, that gains you some time for doing something intelligent. That also helps you.
Thank you. I'm going to ask the other panelists to comment, but before I do, anyone who has a question, raise your hand so we can get the mic to you, okay? Other panelists, do you wish to comment on the autonomous operation in automation? He captured it so well, didn't he?
Well, I will say I like Bernard's comment about it was essentially use the right tool for the right task. He said, you know, some of our problems that we see them very infrequently, or it's not easy to pull out of the data, and that's the time that we'd want to use something like artificial intelligence. So I think that's right. We need to make the right investment with the right tool for the right problem, and define what the right problem is we're trying to solve and address.
Okay.
The other point I'd make is the infamous word integration. There are a lot of things you can do out there to provide operator assistance, what have you. It can be quite costly. I mean, you want to find solutions that are as pre-integrated as possible. Bernard, you mentioned both horizontal and vertical communications. That doesn't come for free. So when you're looking to increase your level of autonomous operations, you need to look for vendor solutions that use standards, as Jonathan mentioned, such that the cost of implementing that next increment of autonomy is not prohibitive. So a lot of things you could do, but you have to have a foundation and a technological path or architecture that does not cause you excessive amount of money to implement.
Mm-hmm. Thank you. Audience questions. Raise your hand or we're going to call on you. Please.
If there's no question, there's maybe one more thing that I would like to add, and that is, I guess everybody who has invested in automation is interested in keeping the value and increasing the value of the investment, rather than throwing out the investment in favor of something new that should solve all of the problems of the world. And I guess what is important for doing that, in order to bridge this gap between the need for having very reliable, deterministic, safe, robust operations that never changes, and this world of always changing things, well, what does machine learning do? It actually tries to create new knowledge out of data. In order to bridge that, you have to actually have a separation between this very robust inner core that you basically want to run 24 hours a day, 7 days a week, and then something, and Steve has called it edge, yeah, something where you can actually apply all of the new things, but then you also need a seamless integration, cyber secure, of course, that connects the two things. In order to, for example, bring this R that Mike was talking about back to the control system, learning that you actually want to apply to make a change of the set point. And I think the main thing that automation suppliers should provide is something where your investment is actually kept over time, while every new development in technology can be added later on. And I guess that's an important thing that you would have to look for in your implementation of your automation system, as well as extensions of the automation system towards autonomous.
Okay. Questions from the audience? We got one.
Okay, so I think, is this on? I think this is for Jonathan from Dow, because I really like the comment about heritage or legacy sites versus new sites, and maybe to the two ExxonMobil guys. If you compare something that you are limited from a heritage site to building a greenfield site with the best available technology today, can you quantify the difference in productivity or automation, or how big is that gap from the worst heritage site to probably the best you can build today?
From a value creation standpoint,
From an automation standpoint, from a profitability standpoint, I mean, there's always limits because you can spend through the roof. But what I'm trying to understand is how big is that gap? Because technology is, what's that?
Is it worth chasing?
Well, yes, because technology is improving at an exponential rate, so it's going to keep going. But if you just look at today, can you sort of quantify the gap between those two?
yeah. So a number that we've done some internal benchmarking against industry, we say state-based delivers about 2 to 5% AC improvement from state-based versus the manual operation. I think a piece of what you've got to quantify, though, is speed of delivery, and then also all of the safety ramifications. So, when you capture that control system configuration, when you capture your operating discipline in the control system itself, the control system doesn't lose sleep or have arguments with significant others or any of the other world stuff that's going on. So it's always going to execute. So, the dollar value, that's fairly easy to quantify, 2 to 4% more throughput. The process safety standpoint, though, is where I do struggle a little bit to be able to convey there is significant value in doing this. But if you can quantify a dollar value to the process safety, I mean, it becomes then it's an opportunity of, hey, this could happen, and that I don't get too much success in getting projects funded on, well, this could happen. But I think it's one of the reasons I tie back to what's your operating staff. It's young. It's less experienced. It's less experienced and higher experience level. We're about to lose a lot of process knowledge. So I do believe we're setting operations up for greater chance of making a mistake that could result in something bad. I think there's got to be inherent value in that. We cannot quantify it, but there's value in that. And then if you've got repeatable installations around the globe, like a lot of Dow does, or hopefully a lot of us do, once you make an improvement in somewhere, it is very quick to leverage that and that benefit from that one plant across the globe, regardless of how big your installation is. So I think the bigger you are, the more leverageable and the higher the total value creation you're going to see. But, Steve,
Thanks. We have a few minutes left. Oh, go ahead, Steve.
Yeah, I mean, okay, so I want to react to your question and also something Jonathan that said earlier about the infrastructure. So when I was watching the presentations, I'm thinking ExxonMobil in particular has put a lot of money into detecting abnormal situations. Statistical based, rule based, everywhere across the planet. And then we provide those to the operations staff through an alert or an advisory. And the operator looks at it and says, okay, maybe I'll take some action. And then on the back end, we'll put procedural automation on the back end where you push a button and you react to it. And you say, okay, safe park the unit, cut the rate, change this operating mode, maybe shut down. But we always put an operator in between. And at first thought, you might think, well, this is just fear of changing and fear of progressing and moving to new technology. But I think the problem originated back in the 1970s, and I'll tie it back into your question. When I started in this business, there were pneumatic signals. So when you wanted to get a sensor or actuator back to a control room, you had to run a tube, and then you had to pour soap on the connections and make sure that no air was leaking. It's very expensive and very complicated. So we learned how to instrument our plants absolutely bare bones minimum for safe and reliable and profitable operation. Not a sensor more, And the funny thing is, that culture is so deeply ingrained in our DNA, even when we build greenfield facilities, we still go back to that same, why do we need that extra sensor? So you commented on greenfield versus brownfield. I think the reason that quite a few in industry are afraid to close that final loop is that in a brownfield facility, it's so ridiculously expensive to add the sensors that you need to make that decision correctly and confidently, to take the operator out of the loop. And so Jonathan mentioned you need that infrastructure in the base. If you're not willing to make that investment, I think you're always going to keep the operator in a loop. But the greenfield site, that's the opportunity to get it right. That's the opportunity to go in front-end engineering and say, these are the things we need, and able to remove the operator from that decision-making loop, not follow the pattern of 40 years ago.
Thank you.
John has a question.
Thank you.
So one of the questions I had was designing autonomous versus managing autonomous are two different things. I was hoping any of you could comment on designing autonomous plants versus managing autonomous plants. And do you see them as the same thing?
I would say there is a difference in managing autonomy, and my experience is that in the past the human beings didn't. It's a trust issue. It's a trust issue, and so we have operators or engineers in the loop because we don't trust the sophistication of the applications or the hardware that's running those applications and working. I mean, Steve's presentation was very heavily based on redundancy and availability of the supporting infrastructure to run these applications. That's what builds trust. You know, 5 nines or 99.98 or whatever. You need to have that foundation to build the trust, and we've not had that. Electronic technology has improved greatly over the years, so we've not taken credit and improved the trust level to allow us to do advanced AI type applications or machine learning. But you have to take this gradually. If you put in an advanced application immediately into a refinery or a commodity chemical plant today, it will be rejected.
Yeah, let me just make sure I clarify my question.
Bernard? Oh, I'm sorry.
Let me just clarify. So when you talk about AI, right, you're learning from the system.
Yes.
But it's possible, I mean, some of what Steve talked about with building redundancy into the system, that is a form of designing autonomous. And so when you decide to put in sensors into the environment, right, and you're putting them in with the idea of you're designing an autonomous system, that's very different than actually building a system that is essentially learning from the existing environment. So you didn't really design in autonomous, you actually built on top of it.
Right.
And I think there's a big distinction between those two, and that's what I'm trying to get out of that. Right. So, I agree with you, trust is part of it, but there's a design challenge and then there's a management challenge. Both of them are related to autonomous. That's right. What I'm trying to understand from the panel.
Right.
The answer, I think, fundamentally is as we are learning we as human beings are learning how to not only design this in from the beginning or retrofit it after the fact, and it is a collaboration between those two environments. The science is ahead of the trust right now.
Got it.
It's ahead of it. Right?
Good. Bernard?
Yeah, well, as a designer, you always want to do the best. So if you think, let's take a completely different example. If you think about somebody constructing an aircraft that flies without pilot, what you try is that this airplane really does the best it can do in all situations that you can envision. Now, every redundancy has its limits. And there are always situations that you haven't foreseen, because finally the design is always done by people. So managing it means that in spite of the designer actually having done all he or she could to make it work in all situations, to deal with those situations where it didn't work properly. And that's where the people aspect comes in, because that makes it even more difficult for the people in the control room, if you still have some, to react properly, because they are not used to that reaction anymore, because 99.999% the system does the right thing. Yeah, and so I guess that's the responsibility of the operator to still think for these cases where the system, with the best of all intentions, doesn't work perfectly, how you deal with that. And I guess if I'm allowed for one small commercial, we will have a lunch session tomorrow where we will discuss a bit what my company ABB does in these kinds of things, so that might be interesting to listen to.
Okay. All right, we're out of time. I do thank you for your attention. It might not show, but I'm a lot smarter now than I was 90 minutes ago. So I want to thank the panelists and the speakers. So please give them a hand.